2 of chapter 3 is called Angles Formed by Parallel Lines. So we're going to draw 2 lines. We'll call this line P, and we'll draw a second line, call it Q. Okay? These 2 lines, we're going to put a special little symbol on them that kind of looks like a little arrow pointing like that. Those 2 little symbols are called carets. And those 2 carets represent that those 2 lines are parallel. Okay? So when you have the 2 lines parallel and they're cut by a third line, we'll call that line T. That's the transversal. It's going to create 8 angles. So we'll number them 1, 2, 3, 4, 5, 6, 7, 8. Okay? Numbered slightly differently than what you saw yesterday, but that's good to get your brain working a little differently. When these lines are parallel, there's going to be special postulates. So the first one is called the corresponding angles postulate. All right? So we're going to talk about all the corresponding angles that are in this diagram, and they're going to have a special relationship. All right? So what do you think the corresponding angle special relationship is going to be? Okay, so let's start with angle 1. Here's angle 1. We're going to travel down the transversal. Which angle is in the same position? 3. So angle 1 and angle 3, what do you think they are to each other? Anybody want to guess? They are corresponding. Yes, we already identified that they're corresponding. They are what we call congruent. So angle 1 and angle 3 are going to have the same measure. Okay? Same thing with angle 2. We're going to follow that down the transversal in the same corresponding position is angle 4. Guess what their relationship is? Congruent. Then we're going to jump over here to angle 5. Follow down the transversal. Same corresponding position is angle 7. Guess what their relationship is? Congruent. Okay? Now let's look at angle 6. Follow down the transversal in the same corresponding position is angle 8. And they are obviously congruent. There are 4 pairs of corresponding. That's the one with the most, right? The one with most pairs. All right. Let's look at another pair of parallel lines. So we'll call this line A and line B. Move it up just a little, shrink it. There we go. And we'll cut them by a transversal. We'll call that line T. And this theorem is called the alternate interior angles theorem. So yesterday we just identified the alternate interior angles. Today we're going to talk about their relationship when the lines are parallel. So let's number only the interior ones. So the ones between the 2 lines A and B, right? So let's number 1, 2, 3, and 4. I don't need to worry about the other 4, right? Just those 4 interior ones, okay? So if you look closely, and we start with angle 1, follow down the transversal, which angle is going to be the alternate interior angle to angle 1? 4. So angle 1 and angle 4 are alternate interior angles. Anybody want to guess what their special relationship is? What? Yes, they have the same measure. They are what we call congruent. So we're going to say that angle 1 is congruent to angle 4. So if that one is 45 degrees, then angle 4 is 45 degrees. Okay? How about angle 2? We follow it down the we start with angle 2, go down the transversal. The alternate one is angle 3. They are also congruent. Okay? Let's draw 2 more parallel lines. This is line C. And here's line D. We're going to put that little, oh, I forgot to put the caret on this one. Sorry, go back up to A and B and put the little caret on there. They are also parallel. C and D are parallel. They're cut by the transversal T. And the name of this theorem is the alternate exterior angles theorem. Okay, so on this one up here, I only labeled the interior angles, right? So on this one, because it's the alternate exterior angles, I'm only going to label the exterior ones. So outside of these parallel lines, I'm going to do 5, 6, 7, and 8. Okay, so let's start with angle 5. All right. Here's angle 5. We're going to travel down that transversal. Which of these two is going to be the alternate exterior angle 8? And if you study 5 and 8, what do you think the relationship is between those two angles? They're congruent. So angle 5 is congruent to angle 8, and angle 6 is congruent to which one? 7. Okay? All right, so now in your notes, you're going to draw a line. Okay? The 3 theorems and postulates that are above this line all have to do with congruence. Put your little congruent symbol. Below the line, we're going to have one more theorem, but it's not going to be congruent. It's going to be that the angles are supplementary. Supplementary means that angles do what? Add up to 180, okay? So we're going to draw 2 more parallel lines. So this is line E. Here's line F. Don't forget your little caret, because I often forget them. Okay? These are going to be cut by the transversal T. And this last theorem is the same side, interior, angles theorem. Okay. So we already did the alternate interior angles theorem, and those were congruent to each other. So the same side interior, they're going to be supplementary. But I'm just going to label the angles that are between these 2 lines. So we'll call them 9, 10, 11, and 12. And then we're going to find 2 angles that are on the same side of the interior. So here's angle 9. From angle 9, you're going to follow the transversal down. Which angle is on the same side? 11. So this time, instead of saying congruent, I'm going to say plus angle 11 equals what? 180. All right, now let's do the other side. So now we've got angle 10. You follow the transversal down, and on the same side is angle 12. So angle 10 plus angle 12 is going to be equal to how much? 180. Bless you. All right, I'm going to move that up. You'll see it in just a second. There you go. We're going to look at example number 1. All right, so for example number 1, it's going to have 3 parts. So we actually only have one example, but it's just going to have 3 different pieces to it. Okay, so we've got 2 lines. We've got line L and line M. We're going to put this little caret on it, on both of them, to show that those lines are parallel to each other. That means our third line, we'll call it T for the transversal. And I'm going to number the angles. So this one's going to be 1, 2, 3, 4, 5, 6, 7, 8. And then I'm also going to give you some information about some of them. Angle 3 is going to be 70 degrees. Angle 4 is going to be 4x plus 22 degrees. And angle 8 is going to be 5x degrees. All right. Okay, so this question has 3 parts. The first part, part A, what is the measure of angle 7? The correct answer, bless you, she is correct, is 70 degrees. How did she get that? It's corresponding to angle 3. So just write down that it's corresponding to angle 3. Easy, right? If there's a number there and they want the corresponding angle, it's just the same measure, okay? Part B gets a little bit trickier. This time, we want the measure of angle 5. All right, so here's angle 5. Anybody see anything that could be in relationship to it? Yes?
4x plus 22.
Alternating interior angles. Okay, yes, we could say that it's 4x plus 22, but that doesn't help. I mean, that would sort of help if we knew one more measure. What about the one we just used, the 70? Same side interior. So we know that same side interior of angle 3, right? And those 2 angles, same side interior, should have what relationship? They should be what to each other? It's the one that's different from the other 3. They should equal 180. So if this is 70, we're going to say 180 minus 70. We should get how many degrees? 110. All right. Let's try one more, part C. Now let's look for the measure of angle 8. Okay, everybody see angle 8 right here? Is there an alternate exterior angle to it? Yes, you found it. He found that angle 4 and angle 8 are corresponding. That means that 5x should be equal to 4x plus 22. Okay?